This is dilution calculations. So before we get into the dilution, we have to understand what solution is. A solution is a homogeneous mixture of a solute in a solvent. Solution is made up of solute and solvent. A solute is the material present in a smaller amount in the solution, while a solvent is the material present in a larger amount in the solution. The concentration of a solution is a measure of the amount of solute that has been dissolved in a given amount of solvent or solution. So when we are talking about the concentration, we factor in how much solute or how much solution or how much solute or how much solvent is in the solution. Then a concentrated solution is one that has a relatively large amount of dissolved solute. Large amount of dissolved solute. And the dilute solution is one that has a relatively small amount of dissolved solute. When you go to grocery store, you buy 100% orange juice, that's concentrated one. You can have 5%, that's dilute one. We can only relate this to everyday life. Looking at this here, you can see this is highly concentrated and this is dilute, okay? We use this every day. We look at this every day. So let's even look at this some more. If we have this measures concentration, let's say I put this, okay, drink mix, and then with this, I can say the concentration of the drink mix solution. Look at it now. If I put more, the concentration goes up because I have more solute. Okay? What if I add water? What will happen? Look at it. The concentration is dilute now. Less concentration. Okay? So if I keep on adding more water, you see that? But then I can remove all the solute again, start all over again. I put, you see, the more I add, the more concentrated it is. If I try with some other, let me try with this. Okay, I'm adding. The more solute I add, the more concentrated it gets. Okay. Then what if, let me reset. Let me reset, then I'm adding this. Okay. Then I add more water, can dilute. So that's what we mean concentrated and dilute solution. Concentrated and dilute solution. So dilution is a process of adding more solvent to a solution. Adding more solvent to a solution. When additional water is added to an aqueous solution, the concentration of that solution decreases. This is because number of moles of the solute does not change, while the volume of the solution increases. So with this, we can set up an equality between the moles of the solute before the dilution and the moles of the solute after the dilution. Remember, molarity times liter gives us number of moles. Okay? So we can have moles, this together, when we multiply this out, is equal to moles, because molarity is moles per liter. We multiply it is equal to number of moles. What do we equate them? from that simulation, though we added more water to get it to be diluted, the number of moles, the amount of solute there didn't change. Okay, so that's why we can equate them. So we can have this in another way. That's molarity, initial molarity times initial volume equals to final molarity times final volume. And with this, we can solve dilution problem. But before we look into chemistry of this, let's look at what we see in our everyday life. Let's assume you bought 100% orange juice, you're expecting 4 people to come to your house. And all of a sudden, each of them is coming with maybe 5 kids, and the store is closed. You have no other place to get 100% orange juice. The choice you have is to dilute what you have so that it will be enough for your guests. So it says, calculate the volume of 100% apple juice you will need to make 2 gallons of 5% apple juice. How do we do that? Okay, so this is everyday dilution problem. We do this every day. So we want to calculate how much volume. So we call it initial volume, V1. We don't know. And the initial concentration, we call it C1, is 100%. And then we want to make 2 gallons. So the final volume we want is 2 gallons. And the final concentration, the final concentration is 50%. So for us to figure out the volume of my 100% I need to make 2 gallons, I will equate this to each other. Okay, so we need the initial, so we divide this by C1. So V1 will be C2, 50.0%, times V2, 2 gallons, divided by C1, 100.0%. So this will cross out, and we end up with 1 gallon. 1 gallon. So I'll take 1 gallon of 100% to make 50% of apple juice. That's everyday application. Now, let's do the chemistry of this. So this example says, suppose that you have 100 ml of a 2.0 molar solution of hydrochloric acid. You dilute the solution by adding enough water to make the solution volume 500 ml. Calculate the new molarity. Calculate the new molarity. Okay. So let's solve this together. So in this way, it says, suppose that you have 100 ml of a 2.0 molar solution of hydrochloric acid. You dilute the solution by adding enough water to make the solution volume. Solution volume 500 ml. Calculate new molarity. So what do we know? We know that you have, so we have initial volume 100 ml. We have initial molarity 2.0 molar. And then we have, you dilute the solution by adding enough water to make the solution volume So now you have new volume, 500 ml. Then now you have to calculate the new molarity. That's what the question is. And by looking at all of this, the only formula you can use here is this. Okay? So you divide this by, we want to isolate M2, we divide by V2, we divide this by V2. So this crosses. So we will have this to be equal to M1 V1 over V2. So M1 is 2.0 capital M times V1 100 ml all over V2 500 ml. Okay? So the answer will be in molarity. So the answer will be so this will come out to be 0.40. So that's the new concentration. Okay. So we started from, you see the M1 is of high concentration, which makes sense because you added water. And you added water, this is more dilute, 0.40. You have to analyze your answer. It has to make sense. If you don't analyze it, you may not catch your mistake. Pause the video and try this. Try this. Okay. What volume of 2.0% solution do you need to prepare 10.0 ml of 1.2% solution? We know another way of expressing concentration is percent. Okay. We're going in this question again, you're going from more concentrated to more dilute solution. So pause the video and try to solve it. So what volume of 2.0% solution do you need to prepare 10.0 ml of 1.2% solution? The first question you may ask yourself, how do you know if this is dilution problem? So you write down what you know, what volume. Okay, what volume of 2.0%? That initial volume you do not know. The initial concentration is 2.0%. You want to prepare new volume, 10.0 ml, and then final concentration is 1.2%. Okay. So with all of this, given that it's a dilution problem, that's how then you use this. We want initial volume, so we divide by C1, divide by C1, cross out. So V1 is C2 V2 over C1. Now, do we know C2? Yes, 1.2%. Some students may want to do 1.2 over 100. It's not necessary here because the percent will cross out. Then V2, 10.0 ml, divide by C1, 2.0%. You see this will cross out, that's why that is unnecessary. And after you do that, it will be 6.0 ml. That's how much of 2% you need to prepare that solution. Example 2. Nitric acid is a powerful and corrosive acid. When ordered from a chemical supply company, its molarity is 16 molar. How much of the stock solution of nitric acid needs to be used to make 8.00 liters of a 0.50 molar solution? So you have to understand this question. Nitric acid is a powerful and corrosive acid. When ordered from a chemical supply company, its molarity is 16 molar. How much of the stock solution of nitric acid needs to be used to make 8.00 liters of a 0.50 molar solution? So what do we know? We know the initial concentration, M1 is 16 molar. How much of the stock solution of, that V1 we do not know, needs to be used to make the final volume is 8.00 liters, and the final concentration is 0.50 molar. Okay, so clearly we need M1V1 equal to M2V2. So we need to divide by M1 to isolate V1. So V1 is M2V2 over M1. We continue here. So we plug in the numbers. M2 is 0.50 molar times V2, 8.00 liters, divide by M1, 16 molar. So this we cross out. Our answer will be in liters. So this will be 0.25 liter, or you can convert to milliliter. That's it. So we need this much of 16 molar to prepare 0.50 molar solution with a volume of, final volume of 8.00 liters. I hope, okay. I want you to pause the video and do these two problems. The first one is calculate the volume of 2.0% solution used to make 10.0 ml of 0.80% food coloring. Okay. So pause the video. Let's do the first one together. Again, this is a dilution problem. We're going from higher concentration to lower concentration. So we calculate the volume. So initial volume, we do not know. Initial concentration is that. Used to make final volume we want to prepare is that, and then final concentration is 0.80%. Okay. We can go from, we always go, when it's dilution, we always go from higher concentration to lower concentration. So C1, V1, C2, V2. We want to isolate V1, we divide by C1. Okay, so V1 is C2, V2 over C1. So we plug in the number. C2 is 0.80% multiplied by V2, 10.0 ml, divided by C1, 2.0%. This, of course, we cross out. And we end up with 4.0 ml. So that's how much of 2% we need to prepare this. Okay. So hopefully you got that right. And then you do the second one. If you did the second one correctly, this will be your answer. Okay, but you're not done. What if you are given this in the lab? Create 100 ml of 0.005 molar copper 2 nitrate solution from 1 molar stock solution. Or create 100 ml of a 0.08 molar calcium nitrate solution from 1 molar stock solution. So you're given this instruction in the lab and you are told to apply it. Prepare this solution. Okay? How will you do it? Pause the video and try to see if you can do this in the lab. Okay? Pause the video. So I give you the application to lab. You will, when you do your calculation, you get 5 ml of copper 2 nitrate. So you measure this into a 10 ml graduated 10 ml. What am I doing here? After you calculate, you get 5 ml of copper 2 nitrate. Then you measure out the 5 ml of copper 2 nitrate with graduated pipette. Then transfer into 100 ml volumetric flask, add the saved water onto solution. You know, where you read, it has to, your meniscus has to sit on the line. And you have to take the precaution and read it accurately. So that's one way that there's always solution preparation in lab is so critical that you know how to do it, you know the technique, and you know the calculation. Okay, I hope this makes sense.